Welcome to this tutorial. Today we're going to look at how to integrate Smart Cover System with Lyra. The whole process will be in Blueprint on UE5.1. All you need to prepare is a fresh copy of Lyra and SCS. First, we need to make sure two plugins that SCS depends on is enabled. So in your Lyra project, go to Edit, then Plugins, search for Warp. We need Animation Warping and Motion Warping. Since Lyra already have one enabled, just enable the other one and do a restart. Then we can go ahead and migrate the contents from SCS into Lyra's content folder. Just click on SCS folder and migrate everything. Now that we have SCS contents in Lyra project, we can set up the skeletons to be compatible. This way Lyra and SCS character can share the animation assets between them. And it's easy to set up. SCS1 is in this folder. Open up. In the window menu, click on Asset Details. Hit plus. Search for escape_mannequin. This is the Lyra skeleton we are looking for. Then double-click on this asset. It will open Lyra skeleton. Do the same, but select the one from SCS's folder. Save everything, and if you search for cover in the Anim Asset window, you will see SCS animations are already available. We also need a clean workspace for testing. See, his demo level should do just fine. Located in this map folder. Let's make a copy into this over here under Shooter Core Contents. Now if we load it up, and in the default game experience, select B_basic shooter test, and clear out the game mode. We should be able to load only the player character when we hit play. This will be our testing ground. Looks like the character fell off. Let's expand the level a little. Now it's time to integrate the logic. Most of SCS's logic are kept in the BP_SCS component. So find our B Hero Shooter Mannequin. This is the player character class. In here we add SCS component. Drag out a reference. From begin play, we can call the SCS initializing function. This will require us to input a couple references and some defining variables. For now, we just need to focus on the more important ones. We'll circle back for the rest of them when the time comes. First on the list is a motion warping component. It's from the plugin we enabled, so add it into the component list. Then drag out a reference. Put it here. Then we need to set the SCS montage data asset. This contains the montage we need for things like enter or exit cover. So make sure to select the UE5 one. Speed out of cover. Let's set it to 600, which is Lyra's default running speed. In cover, though, we can set it to 100 or 150. I'm gonna leave it at 100. Now we need the input action to trigger enter or exit cover. For that, we need to first add the input action into the mapping context. In the content folder, under Input and Mappings, you will see this IMC called Default KBM. This is what Lyra Character Controller is using for Shooter Core content. Open it up and add a new input action. Search for IA_enter exit cover. Let's bind the key to Z. And for trigger, select tap. Now the controller should be able to recognize this action. Back in Hero BP, let's add the input into the event graph. When triggered, we want to first check if the character is already in cover. Get another SCS component ref. From this we get an in cover Boolean value. To a branch, if in cover, we drag out a call to RPC_SCSS exit cover function. If not, we need to check if we have found a cover near our character. Get another Boolean called cover found. Branch, if true, we can the RPC_SCSS enter cover function. That hopefully will get our character into it. Now we can test it in the level. If you go near a cover and press Z, you should see the character moving in. We are now snapping onto the cover and can only move alongside it. Press Z again will move the character out of cover. It's not playing the in-cover animations because we haven't set it up yet. So let's go set it up in the anim BP. The ABP we need is called ABP_mannequin_base. First thing we need to do is implement an animation interface. Under class settings, add, select ALI_cover AO. You will see two linked layers, one under SCS, the other one called SCS control rig. We can make use of these by creating a new state machine called cover. We need to use this pose inside this state machine, so let's first save it to a cached pose. Call it non-cover locomotion. Inside cover state machine, we will create two states. First one called non-cover, the other let's just call it cover. We also need a transition rule back, so drag a line out back. Now we need to feed in the pose. Inside non-cover, we bring in the pose we just cached. Then inside cover state, first we need a linked anim graph. In the instance class, search for SCS layer. Then drag this link anim layer and link it to cover AO layer. This is like a doorway for different aim offset graphs to come in. Now we need to set up the transition rules. Go to Blueprint Thread Safe Update. This is a new way to multi-thread update values. All SCS values will be acquired within this function. Before we get the values we need, first create a new thread safe function. Call it getSCSComponentThreadSafe. Mark it as a pure function and inside advanced. Check thread safe. Now let's add an output. Variable type is BP_SCS component. And this part is very important. To be able to get the value from this function, we must name this output as return value, no space. Otherwise, we might not be able to get anything using property access. This goes for all thread safe functions. Just keep in mind. To get a reference of SCS component, we need to first get the reference of our character. So create another function. Let's call it getCharacterRef. Same as before, pure and thread safe. Add a return node. Variable type we can set it to Lyra character or character. I'm using Lyra character. Name it return value, in case we need to grab a value from the character BP later. Now we need to get a pawn reference. We can do this using property access. In the drop-down, we can select this function called tryGetPawnOwner. This will return a pawn reference, which we can cast to Lyra character. If the cast is successful, we set the return value with the new reference. If not, we can do a print log or something. Now we can go back to the previous thread safe function. Similarly, using property access, we can access the return value from this thread safe function we just made. Using this character reference, we can try calling a Blueprint interface to get its attached SCS component. Back in Blueprint Thread Safe Update, near the end, we can use property access again. This time we are not just calling getSCS component function. We can access a value from it, and the one we need is in cover. Promote it to variable here and put it in front of this is first update setter. We can check if we are getting this value. In Event Graph, let's bring out Event Blueprint Update Animation. Do a print string for in cover. Animation isn't playing because we haven't linked up the poses yet. In the cover state machine, we can add the in cover value as transition rule. So we go to cover pose when in cover, back to locomotion when not. For blend settings, this is what I recommend. We give this one a 0.3 seconds blend time and 0.1 for the lower one. Go back to anim graph. Remember to save this state machine to this cached pose. Now should no longer be T-posing. Since we are already here, might as well set up the animation slots so the montage can play. Next to cover state machine, we can bring out the cached pose we just saved. Give it a slot definition. These slots are not what we needed, so we create what we need. In the asset browser, search for a cover montage. For example, stand to cover. We can check the slot name defined in SCS. The three of them are loco body, loco left arm, and loco right arm. Back to ABP. Under Window menu, open up Anim Slot Manager. Here we can add those three slots. Under default group should be just fine. Now we can select loco body from this slot node. We need to make 2 copies of these nodes. The first copy set the slot to loco left arm, the other loco right arm. Then we need to catch these poses. First one we call it locomotion body, then one left arm and one right arm. Now we need to blend these nodes using a layered blend per bone node. First grab a locomotion pose and a locomotion body pose. Then grab a layered blend per bone under layer setup. We need 2 elements for branch filters, one for clavicle_R and one for clavicle_L, with blend depth both set to 1. Put locomotion body to base pose and locomotion to blend pose 0. We need another layered blend per bone node. This one we need only 1 element for blend pose 0. So remove clavicle_L, but we will need another blend pose. Add a pin. Get a locomotion right arm and a locomotion left arm pose. Right arm to clavicle_R pose and left arm to the second one. We didn't set up the branch just now, so add an element under index 1 and clavicle_L blend depth 1. Good enough for now. Let's save this pose to use it later. Call it locomotion with cover. Down here, we need to replace this locomotion pose with our locomotion with cover. Then it's time for a quick test. Now if you move close to wall and press, you see the lower body is already playing the enter cover animation. But there's an issue. The print string value says false, and we are not playing any in cover animation. That means we failed to get the value. Ignore these errors for now. We will deal with them later. We failed to update the in-cover value simply because we didn't quite get the SCS component from the interface call. Go back to B_hero shooter. In the interface list, we only have Lyra default ones. Let's add the SCS interface. In class settings, we need to add a new interface here called BP_cover interface. Now we can see this try get SCS component interface showing up. Double-click in here. We need to put in the SCS component. This way, when the ABP is calling this interface on our character, it will hand over this reference. If we test again, in cover animations are showing up. A couple minor tweaks though. First, let's just set both of these blend weight to 0. This way the unarmed enter cover animation won't affect how the character holds the weapon. Second, we need to move this part from full body, aiming to apply additive. Move them all the way to the beginning. Add it behind a locomotion state machine should done just fine. Then we need to replace this cached pose as well, with locomotion with cover. A quick test. Now, the enter animation won't affect how the character holds the weapon, and Lyra aim offsets isn't affecting our in-cover pose anymore, which is good a start. Next up, let's get the character to start walking in cover. We can find a linked anim graph in this folder. This is the link anim graph we added in the cover state machine, and it handles the in-cover locomotion. Same as Lyra. This graph used blueprint thread safe update for variable update, which we should be very familiar by now. But to get the correct value, we need to first make sure we are accessing the correct reference. Go to Get Main Anim Instance. This is trying to get the SCS demo anim graph as a reference. We are not using that one. So let's do another cast. this time cast to ABP underscore mannequin underscore base. We need to switch out the return value type as well. When we do something like this, a lot of errors will pop up. We will fix them right up. First, need to get main anim instance. Then we need a speed, which is not in Lyra anim BP. We also need a value called firing, and one for ADs, one for dual wield status, and a weapon type as well. First, let's get a speed value. We can't get it from the main anim bait because there is none, but we can work out the value pretty quick. Property access. From get character reference, let's get the velocity vector. Then we can work out its ground speed by getting the vector length xi value. Next up, firing. There's an equivalent variable in Lyra's main anim instance, but there is one in the linked layers. We will get it later. For ads, we do have a value ready to use. Just get this gameplay tag is ADs. Dual wield status isn't important right now. Let's get weapon type first. That should get rid of most of the compile errors. To know what type of weapon is active right now, we need the weapon reference. Unfortunately, there's no direct way to get it from our character BP. One of the easier workaround would be we let the weapon actor hand over its own reference via interface. First, we locate the cover interface BP, add a new function called BPI underscore get Lyra weapon ref. We need an input value. Set the type to B underscore weapon. That's Lyra's base weapon class. Name it Lyra weapon ref. Now let's open up this B underscore weapon. This is the parent class which holds the logic. At begin play, we can get a ref from this owner as pawn and call the interface we just created. BPI get Lyra weapon ref. Get a self-reference and put it here. Then we create a new variable, weapon type. This value, we need to define it in the child class. When a weapon is added to the character, a child class of this is spawned and attached, triggering this begin play function, sending its own reference to the character. We just need to catch it and use whatever property it has on it. For example, weapon type. In case we forget, let's define the weapon types for the child weapon class. In here, we can set its value. Back in our character BP, we can double-click on this interface to create an event. Since by default Lyra character can hold 3 different weapons, and the order do matter, we need to save all of them and their associated slot number. So get controller. Then we can get a quick bar component using this get component from class node, from which we can get active slot index. Make sure it's valid, or the proxy side may throw some errors at us. Then save our weapon reference to an array. Create an array, call it slotted weapons. Now we can set array elements with the ref as item and index as index. Make sure it replicates. Now we can create an event to hit current weapon type on command. We need to update this value when we pick up or switch to something new. So we create a custom event first. Let's call this one RPC underscore update weapon type. This one we set it to replicate to server and reliable. Then we create a multicast function called MC underscore update weapon type. Set it to multicast and reliable. That means server will tell all the proxy to do so. Let RPC event trigger this MC event. We want this multicast event to first get the current weapon slot. From the controller, we get the quick bar component. Then we can access the active slot index. Use this index to get the saved weapon, and then get its weapon type. We can collapse this part into a function in case we need it elsewhere. Make sure to link this MC event call to the newly created function. to make sure both server and client side both get a weapon type value. We can do a print string to debug this value in game. So get an event tick. Print this in them. Duration 0. Now we can make a call to this RPC event when we change weapon slot. Or after adding initial weapon. Now we can give it a test. In our third-person map, we can drag in a weapon spawner. In the weapon definition, let's choose rifle. Now hit play. There are compile errors in the SCS layer. We didn't fix the property access yet. To fix these, we can simply create these variables in our main anim instance. We can't access weapon directly using property access because this reference is cast to a parent class, but we can use an interface for this. In our hero BP, open this interface, break this. These values we can pass on to the anim BP. For now, let's just pass on the weapon type. Now back in anim BP, get a character reference, and then we call BPI underscore SCS get character value. Place it in front of first update. We can break this open and save weapon type. Let's rename this to weapon type no space, or it may not be recognized. Now weapon type errors are gone. But there are still some other errors. That's all right. Let's just create the variables now and set them later. So dual wield status, no space. What's next? Power. This is for bow only, which Lyra doesn't have. So we'll just disable this. Next, combat ready. We get it from interface as well. What else? Firing. There's a boolean in the main anim BP called game tag is firing. That's not the one we need though. We will get the right one later. Just create this var and leave it unlinked. Next, ADS. We already saved the value from the main instance. Just replace this with AD's var. Next one is power again. We don't need this variable, so let's just break this link. Don't forget to remove this extra pin on this AND node. Now we are good. Although, here's something else. This node is not getting a valid value. Let's fix it. Remove the binding. Bind it to speed. Now let's test it in the level. Not printing, probably because tick is turned off. Let's set this to true. Now it's printing. But weapon type didn't update when we pick up. One thing I forgot is right after we get Lyra weapon ref via interface, we need to call update weapon type event. So let's add it here. This should do. Now weapon type is updating properly, and the character can now walk while in cover. But it's not turning around for the opposite direction. For that we need to find a way to override Lyra's input event. The input events are inside Lyra's player controller, which is a CPP class. Instead of overriding it in a child class, we can remove the input mapping context and add our own for in cover movement. So first thing we need is to duplicate the default IMC. Let's call this one AMC_cover_KBM. Let's remove some of these input actions. We won't need crouch and auto run, and jump and dash. Then we need to switch out this IA_move with one specifically for cover system. Let's first go to SCS input folder. Rename this IA_move to IA_cover move. Then we switch out the IA_move in the IMC with the one we just renamed. This IMC is ready to use. Go back to character BP, behind our enter/exit cover event. Get the Lyra player controller, enhanced input subsystem. When entering cover, we add the cover IMC, and then remove the default IMC. When getting out of cover, vice versa. Now we can override the move input, get IA cover move, and a SCS component, call the SCS movement handling function. X goes to LR, Y goes to FB. This should be enough for turning in cover and stopping at the edge. Let's see. Perfect. Don't mind the weapon and hands for now. Let's get rid of these errors. First one says it's having trouble getting SCS component. Click on this hyperlink will bring us to the error location. So the ABP is trying to get value from SCS component when the component is still loading. Let's add branch here. If access SCS component is not empty, we do the rest of the logic. If not, do nothing. Or go straight to set is first update to false. This should get rid of it. It's gone. The rest should be due to missing reference to the camera-related actors. Let's go back to Hero BP. At SCS initialize, we are missing two references. First is child actor camrail. We can add a child actor in the component list under capsule component, and the actor class, we need to select BP_SCS_camrail. Place it here. Then with camrail selected here, add another spring arm component under it. Grab it and place it here. Let's see. Perfect, all gone. If you go to the viewport of Hero BP, this child actor is perfectly centered, and the camrail as well. These two are used to move the camera around when in cover, so the cover won't obstruct our view. Usually one camera is enough, but Lyra's camera component is inherited, and we can't place it under the camrail or spring arm, so we need to add our own, and set up a smooth camera switch. I will show you a new way to do this. First, we need to create a new camera actor. Name it Child Cam. Right-click Blueprint class. Search for camera. We will use this one. And call it BP underscore in cover cam. That's it. Back in Hero BP, under Spring Arm component, we add another child actor. For the class, let's select BP underscore in cover camera. We use this instead of adding a camera component because we need to use this node called Set View Target with Blend. Get player controller, and then we can call this function. This is used to switch to another actor's view, which will require an actor class reference. There are some tutorials out there using multiple camera component and set one of them active and then lerp the camera positions. Does the same thing but a bit more difficult to manage. So this is my recommended way. We grab this, but this itself is actually a component reference. We can get its child actor reference like this. Now we can connect this part. Blend time, let's set it to 0.6. Blend function linear is fine. When we get in cover, we switch camera. Let's create an event. Call it cam transition, then add a branch. If BP SCS components in cover value is true, we set Lyra default camera to inactive and our new one to active. If false, reverse that. We call this function when we get into cover, so make an event call here after we change the mapping context. Now when we get into cover, we should see a smooth camera transition. It happened, but not how we wanted it to behave. That's because this in cover value is updated after the enter/exit cover montage is finished. So by the time we call cam transition, it hasn't been updated yet, but it's simple to fix. We just swap out true and false. This should do. That's better. You probably noticed in cover cam has blackout areas, which is not like Lyra's camera view. We can edit the settings in child actor template. Under camera component, camera options, we want to uncheck this constrain aspect ratio. Now that's much better. Although centered view in a third-person shooter isn't ideal, so we can offset the spring arm at the socket. Y-axis 60 degrees should be enough. Don't change target offset. It does different things. Arm length 300 should be good. One more thing. We can't rotate the camera in cover. For that we can go back to Hero Big. Check this option for the spring arm. This will allow us to control the camera rotation. When we are in cover and turning around, SCS will send out an interface call to our character to offset the camera. Let's add it into our blueprint. We can copy the code from SCS demo character. We should only need this bit. Let's paste them into our Hero Babe. Create these variables in this blueprint, but not camera boom. We can replace it with our spring arm. Same thing. In the interface list, find this one called BPI Camera Offset. Double-click to create an event. Place it here. Let its output value to set this boolean. Then we need to give them some default values. This is what I recommend. You can try your own setup. Make sure to also check if the timeline is copied correctly. It should look like this: 1 second long from 0 to 1 with a smooth easing in and out. Let's give it a test. Looking good. Behind tick, let's also set the AD's variable we just created. We set it with the gameplay tag Lyra's using. Has matching gameplay tag. The one we need is this event, movement adds. Setting it alone isn't enough. We also need to call the camera offset event when we need. Right after tick, let's add a sequence. First one goes to the setter. Second one, we do a value check. We can use this macro I made. ML value change. Check ADs. When changed, we call this camera offset event once. This only triggers once, so you don't need a do once node here. Use camera left value here. Now if we get in cover, we should be able to aim down sight. Good. We are almost done with the in-cover camera, but let's finish this after we set up the in-cover firing and aiming pose. In our main anim BP, we already set up the anim layer interface, but we didn't specify which layer to link because we need to dynamically link the required layers based on the weapon we are holding. We can copy this part of the code form SCS character as well. So in this blueprint, open up ABP Mani. The linked layers are in the event graph. We can copy this part, paste in our event graph. We need an event blueprint update animation. This is for checking these several key variables. If any of these change, we switch the link layer to a new one, which is selected based on these conditions. Need to replace a couple variable references. First, character. We can use property access for this one. Instead of accessing character, then get mesh from it. We can directly get mesh from it. Then ADs. Use Lyra's tag as adds variable. Can move as a variable from SCS component. Let's create it first, then set it. Inside blueprint thread safe update, we can get it from SCS component using property access. Place in front of his first update. Dual wield status is already set. Now we need another variable called combat ready. If this value is false, no in-cover shooting or aiming animations will play. We already set it here, but didn't feed the value into the interface yet. Back in Hero BP, look for this interface SCS get character value. Let's create a variable called combat ready, place it here. Lyra character was given a pistol when loaded. We can disconnect this so the character will start with no weapon. If you want to apply some other functions like dropping weapons or putting weapons away, then you can write your own logic to turn this value on and off. I'm just going to make it a variable and set it with this weapon check. Let's test in the level. When loaded, it's true. Now if we bypass add initial inventory, when loaded it's false. Character is T-posing because Lyra didn't link the unarmed animation layers by default. We can link it here after combat ready check. Test out OK. Now add a branch behind combat ready, if false. We line the unarmed layer. Now if you bypass add initial inventory, unarmed animations will play. Then what we need is firing. Lyra's has a gameplay tag as firing value in the anim BP, but that one means the character is actually shooting. What we need can be found in the linked layers, so this one we won't use the interface to get value. Next one is dual wield status. This is important for holding weapon in left hand. For now, let's just create the variable. ADS, we already have it. These two we will use later. Now firing. The value we need can be found in this anim BP. Item anim layers base. Search for hip. We need this one. Hip fire upper body override weight. This is a variable to tell the character to maintain a high ready stance for a couple seconds. Far as I know, we can't access this value from our main anim instance, so we need to recreate this in the other graph. Open up this one, says update blend weight data. Copy the logic over in here. Connect and create the missing variables. This bool doesn't have a setting in the other graph, just set to false. So let's just create and leave it as it is. Now these property access we can replace with the vars we got. Is crouching, ADs, and is on ground. Same for these three. Now raise weapon after firing duration. This is a constant as well. Default value set to 0.5. Let's do the same. This access we can replace with existing var in the graph. Then hip fire weight. This is the result we need. Create it. Aim offset blend is irrelevant here, but let's just create it. Root yaw offset replace with existing one. This one as well. Now we save and compile. The errors should be all gone. Let's test this value, see if it's setting correctly. The value is 0, but when you fire it's set to 1, and after a short period, it slowly approaches 0. Perfect. Let's make it official. Use this float to set firing. When it's one, firing is true. Below one, it's false. Now we can begin to test if the linked layers are correct. When in cover with a pistol, it's pointing up. If we get a rifle, the hand is pointing down. We can add a print string to show what layer is being linked. Good. To better see what our in-cover pose look like, let's bypass the skeletal control layer for now. Also, since the weapon bone isn't animated in SCS animations, we need an IK setup to fix the gun rotation and location. Actually, instead of bypassing this, it would be better to modify it. The IK setups are packed inside this layer we just opened. The rest of Lyra's layers are child classes from this one, which means we just need to fix it in here, and the other layers will have the same fix. Under Item Anim Layers, open up this one full body skeletal controls. Let's catch the input pose and bring out the cached input pose here. We can add a blend poses by Boolean in between this two bone IK and foot placement. Let's link this back to the false pose. Connect the output. Then for true pose, get another cached input pose and add a transform modify bone node here. Technically, this is not IK, just skeletal control, but it's perfect for this situation where we just want to change the location of a non-mesh deforming bone. First, we need an alpha to turn this on and off. When we are not in cover, we are using Lyra animation and won't need this to fix the bone transform. So let's get an in-cover value from the main anim BP. Use property access. Turn it into a float. Then the bone we want to modify is weapon underscore R. Translation mode set to replace existing. And for translation space, we use parent bone space, which is hand underscore our bone space. Rotation, we want to replace existing as well, and in parent bone space. For scale, we want to make sure it's ignored, because Lyra scales down this bone, and the weapon attached to it when switching weapons. We don't want to interfere with that. Now for the vector and rotator value. You can copy these values. I used variables here because it's easier to debug, but you don't have to since there will be nothing setting these values. Now we can get another in cover value here to switch between these two branches. Then it's time for a quick test. Great. Get a rifle. That's good. Before we get to other skeletal controls, it's best we get the in-cover aiming and shooting poses set up correctly. Because right now it looks like this. No aim offset, and it's not behaving as it should. This is because SCS aim offset layers are using property access as well, but it's accessing the SCS main anim graph for these values, which we are not using. So go to SCS animation folders and open up ABP SCS cover AO base. In here, we can find this get main anim instance function. Instead of casting to ABP underscore mani, let's cast to ABP underscore mannequin underscore base. We also need to change the return value type to this class. This will generate some errors. Need to replace these. Now AD's value is good. Firing is not, probably because we left it unconnected in SCS layer. So go back to the thread safe update and connect this. Test out fine. But as you can see, for the aim offset, pitch is working but yaw isn't. Because Lyra's yaw calculation is different from SCS and ATPS. So let's create our own aim yaw value. Go to our hero BP, find our event tick. Remove this, add a branch, get an in-cover value from SCS component. Might as well add a switch has authority in front. Then get a control rotation and grab our mesh. Get the socket rotation of root bone. Do a delta rotator and break it into axis. We just want Z yaw. Let's check the value first. So forward direction is 90. We need to zero it. So subtract by 90 degrees and normalize axis. Then promote to variable. Let's call it aim yaw in cover. We need to set it to replicate it, and do a print string just to see the value. Good, now it's zeroed in forward direction, and we have a minus 180 to 180 range. We can use this now. Pass the value through interface. In our ABP mannequin base, we can grab this value and promote to variable, and place it in front of his first update. Now switch out the property access of aim yaw to our new value in the SCS layer. We also need to do this for the cover AO base layer. Good, now we have correct aim yaw and cover. Let's set up the switch hand function so we can test out how two-handed weapon look like in cover. This part of logic can be found in the SCS demo character BP. Let's go find it. In event graph, we need this part, so copy all this and paste it in our hero BP. These interface calls are from BP cover interface, which is already in place, so won't be a problem. But we need to change this from hander socket to weapon R-bone. Don't need to change handle socket. Change this one to weaponer as well. Now for this hander grab temp. The location and rotation rules are set to keep world relative. We don't need to change these to weapon underscore. Now we need to replace the reference. It would be better if we save current Lyra weapon as an actor reference. Let's find our get Lyra weapon function. In here, I don't think we need this as valid check. Let's remove this. Promote this to a variable. Call it active Lyra weapon. Compile. Lots of warnings. Let's replace the reference. Now all of these interface calls are triggered by anim notifies, and we can find those notifies inside ABP Mani in SCS folder. In Event Graph, we need to copy this part into our main anim instance. Missing character reference. No problem, we will replace it with property access. We need to copy this part as well. From BP underscore third person character into our hero shooter mannequin. Now this event is triggered in the SCS component. Without it, we can't even play the animations. Let's paste it here. Missing functions. We want to do nothing because those are events, not functions. This one isn't recognized. And this one as well. It's fine, we can just make another event call to replace it. Replace the variables as well. MC switch hand. Make sure the values of these setters are correct. Now we don't need the last two for Lyra, so let's just remove them. These two map variables we need to create and fill in the animations. We can use the other BP for reference. Let's do two-handed first. Browse to this, and in here we can add an element. Then insert, set this one to two-handed. Next one is bow. Then one-handed. We need to do the same for the reverse. Now we can add a print string here to make sure this is being triggered. SCS won't trigger switch hand for one-handed weapon, so we need to get a rifle. Great, the animation is playing, but twisted, and weapon is attached, but attached to the root bone. Let's fix this. It's attached to the root bone because it can't find the socket we specified. We can copy this from SCS Skeleton. Hide bones. We should only need this one, hand_l socket. Click on our Lyra skeleton, select any bone, and just paste socket. It will be under the original bone. Let's give it a test. Now it's attached correctly. But when switching back to right hand, the gun is rotated. We can go back into Hero BP and get a root component from Lyra weapon and set the relative rotation ZYAW by -90 degrees. Let's see. Perfect. Let's go fix the animation. In our main anim instance, at this upper body lower body split, we need to select this layered blend node and uncheck mesh space rotation blend. Let's test it. That's much better. And reloading animations are fixed as well. Although as you can see we need an offhand reload animation and a whole set of offhand aim offsets. There's no offhand weapon handling animations, but we can make some using mirror data table. In the main anim graph, this linked layer is the aim offsets for different weapons. But since Lyra aim offsets are not for upper body alone, we can't simply mirror this, because the locomotion animations will also be mirrored, and this will generate some weird results. So we are going to make some changes in this graph. Inside ABP item animation layer base, go to full body aiming. Let's make a copy of these nodes, then search for mirror. The mirror data table is included in the SCS project, just need to select this one for UE5 skeleton. Since we only want to mirror the upper body animation, let's add a layered blend per bone at the end. The base pose will be catched base pose, so this part isn't mirrored. Then we link the mirrored AOs here so it plays on top of it. For layer setup, let's use branch filter, and we want to start at spine_01 and set blend depth to 8. Make sure to check mesh space rotation blend. For the base pose, we can't use the cached, because it would make the hand swinging the same way as the leg. Looks very unnatural. So let's get a sequence player. Expose the sequence pin. The anim sequence we need to play is either the standing or crouching hip fire pose. Select base on the bool variable of crouching. Let's use property access. Then we need two animation reference. Search for hip. Crouch pose goes to true. Now we need to switch between these two. Get a blend by bool node. The condition is our dual wield status equals main hand only. If so, we play the upper one. Then we set blend time to 0, in case it caused some blending delay. We still need the yaw and pitch value. Pitch we can use as it is, but we need to invert yaw value because the animation is mirrored. So let's multiply by -1 now. We can put it to a test. Looks like the IK is messing up our pose. Let's disable it for now. Also, there are these errors popping up. Instead of using property access, let's save it to a variable inside the blueprint thread safe update of this graph. Let's paste this value and promote to variable. This way, we won't be accessing this value too early before we finish loading the asset. Now we can use this bool for the select. Then for testing purpose, let's disable IK for now. Also, we can go to our hero BP and add an extra input to manually switch hand. That's good, but still, we need to reset dual wield status back to main hand only when switching weapon. Other than that, we should just need some IK to constrain the hands. Oh, and let's not forget we also need to mirror some montage like reload. For that, we can go to the slot defining part and mirror what we need. Specifically, the upper body slot. Add a mirror node behind it. But for when do we want it mirrored? We need to control it with this Boolean input. One condition is obviously when dual wield status equals main hand and off. But remember, this is not just where the upper body montage is played. Your other animations go through here. So we need to add another condition for what animations are allowed to mirror. Otherwise, the aim offset we just mirrored will be mirrored back. Like this. The easiest way to do this is adding a curve value check. Say if we check for a curve called mirror montage. If the value is 1, we allow the mirror node to function. Just need to add this curve to the montage we would allow to mirror. Like the reload montage. Let's create a metadata, call it mirror montage. Copy this and we can paste it in the other animations. Let's see. Good. Montage is mirrored. Now let's reset dual-wield status back to main when we cycle or pick up another weapon. Just need to add this setter here, right after these switching functions. Let's add a shotgun spawner for testing. We can duplicate from this one, just need to switch out the definition. Looks good. Now we can get back to finishing up IK settings. We already set this up. Still need a couple more to correct the poses. Let's first add 2 firing hand correction IK. That's 2 of the 2 boned IK nodes. First one, we set the IK bone to be hand_R. Effector target also set to hand_R. And for effector location space, we set it to bone space. This means we are offsetting the right hand bone in its own space. When we are holding a weapon in the right hand, we can slightly move the weapon around so it won't poke the character in the face. For joint target, let's use the parent bone space of the hand_R bone. This is for when we are holding the weapon in right hand, in cover and aiming down sight. So let's set up the conditions like this is the alpha to turn this on and off. For effector location, we can promote this to a variable. Call it hand R in cover location. And the value, let's set it to 0, 0, -10. This is what felt OK for me in testing. You can try your own values. For the second 2-bone AK node, we do the same but on left hand this time. So AK bone is hand underscore, effector target set to hand underscore, in its own bone space. Joint target, we use the parent bone space of handle. For alpha, this one is simple. If we are holding a weapon in the left hand, we need this on. For effector location, we need to do a value select. This is how we set it up. If our weapon type is one-handed, we use a vector variable. Let's call this pistol hand L location. Default value, we give it -8, -5, 0. If we are not holding a one-handed weapon. Then do another value select. If we are in cover and aiming down sight, we use a new value. Let's call this one handle in cover location. Default value set to 10, -5, 8. This should stop the long weapons from poking us in the face. Otherwise, we use another value, let's call it hand L location, for not in cover, or not aiming down sight while in cover. Default value, let's give it a -3, -5, 0. These values should be just enough to keep the guns in a reasonable distance from our face, and it's not too far away that our support hand won't be able to reach it. Now we should add another transform modify bone node for left hand, just to tweak the rotation a little. So bone to modify is hand underscore. Translation we want to ignore because A, we already done that using 2-bone IK, and B, this is not an IK solver, it will shrink or stretch the wrist if we move it. Rotation mode, let's set it to add to existing and in bone space. So we are rotating hand underscore bone in its own space. For alpha, we want this always on as long as we are holding a weapon in offhand. So dual wield status equals main hand and off. This is the condition we need. For the rotation value, we need to do another select, based on whether we are in cover. If we are, then use a rotator which we will name it hand L in cover rotation. Default value set to -8, 2, 2. If not in cover, we use another rotator, call it hand L rotation. Default value set to 0, 7, -3. Now for support hand, best way I know is move the support hand in the space of the firing hand. This way, no matter where the aim offset tells our firing hand to point at, support hand will always follow. So add 2 more 2-bone AK nodes. First one we set hand underscore R as the IK bone. effector target is handle, and in its bone space. Joint target is, of course, hand R, and in its parent bone space, because we want to right elbow to bend naturally. For alpha, we need several conditions. First, if we are using hand R as support hand, that means left hand is the firing hand. So dual wield status equals main hand in off. Second one, we need a curve value check. We want to release left hand from IK to perform some actions, like reloading and switching hand. So let's add a get curve value equals 0 here. The curve to check is support hand IK off, no space. Third, we want it off when we are blind firing a pistol from cover. So let's do another select. If we are holding one-handed weapon in cover, we need to decide if we are aiming down sight. If so, we want it turned on. If we are not hold a one-handed weapon in cover, like holding a two-handed weapon, then we need the support hand locked in place, regardless of whether we are in cover. So we must have false checked. For effector location, we need to do some more value select. Obviously, pistols and rifles have different support hand location, and even for the same weapon we have a different support hand pose. Like Lyra by default has a C-clamp pose, while SCS use an old-fashioned support hand pose. So let's first do a select base on weapon type equals one-handed. If so, we select values based on if we are in cover. If in cover, then use a vector. Let's call it pistol hand R in cover support location. Default value set to 0, -5, 3. If not in cover, we use another variable. Let's call it pistol hand R support location. Default to 2, -10, 0. And if not holding a one-handed weapon, copy this select. If in cover, let's create a new vector, hand R in cover support location. Default to 25, -11, 1. If not, create a new variable, hand R support location. Default to 25, -14, -5. Sorry, this was put into the wrong node. Let me move this final vector output to this 2-bone AK. Good, now we can move on to the other support hand IK, which is for hand _L. And that's our IK bone. Effector location should be in the bone space of hand R. Joint target is the parent bone space of hand _L. We want to turn this on when in cover and holding weapon in right hand, but we don't need this on when out of cover because Lyra already handles that. And we also don't want to turn this on when we are hold a one-handed weapon in an idle pose, nor do we want it when we actively turn support hand IK off, so the curve must be 0. With these 4 conditions, the left hand as support hand IK should work. Just need the IK target locations. Similar to before, we use one vector for one-handed weapon and one for two-handed. You can copy down these preset values. Now we can add the support hand IK off curve to some animations, like reload for example. Search for reload in the asset browser. Open up one of the montage. Create a metadata. Name it support hand IK off. No space. So a metadata is a curve with a constant value of 1. Make sure it says 1 here. Now let's do the other 2. Now it's time to assemble all the IK nodes. We just need to link them in the order we created them. Then send the output to this component to local node. Let me move things around so everything looks slightly nicer. Before we move on, we need to add more conditions here. For testing purposes, we only added on condition here. Now we need to use these IK settings when are wielding a weapon in the left hand. So add main hand and off as a new condition. We also want to use the correction IK when we are switching weapons, so let's add a curve value check here. Name of the curve is switching hand. Same as before, no space, and we are checking if this value is above 0. If any one of these 3 conditions are true, we want to use the above IK settings, so use an OR boolean here. We also have this linked layer disabled in the main anim graph, so make sure to put it back in. Now we should be able to test it in the level. We are spawned in with a pistol. Press F8 will give you free flying camera. This is the default Lyra pose. We are just checking if we broke something. It looks fine. Switch to left hand. Hands are still being dragged by the IK. We will fix this later. The offhand pose looks perfect though. That's good. Now let's try rifle. It also has the IK problem, but left hand pose is good. Let's see what it looks like in cover. All good. Now shotgun. It seems both hands are in the support hand pose. Let's see about these two issues. For the iKey issue, we are missing two things. One is at this first iKey node, we only have this one conditions. This fixes the pose when we are in cover. We need this too when we are switching hand. So let's copy this curve value check and add it here with an OR boolean. Also, we need to add this metadata to the switch hand montages. In the asset browser, search for switch. We need to add it into these two for two-handed weapons. For one-handed, search for shield. Pistol switch hand use the same animation as the shield, so add the metadata to these two as well. Alright, let's see. It didn't help. I've had this type of issue before. It's either this curve in the montage is being ignored, or it's being overridden by some of the layered blend per bone nodes. In either case, there's a quick way around this. We add this metadata into the animation sequence instead of the montage. Now let's go back to the testing ground. That's more like it. Let's move on to the left-hand pose. What we are looking for is here. Use a blend pose by bool node. If false, we apply this left-hand override. And we need to save this to a cache pose. Let's call this aim offsets. Then we put it here to run through this interface. If true, we skip the interface. And the condition we need is dual wield status equals main hand and off. That's much better. Next item on the list, we need to apply the SCS control rig when we are in cover. This control rig helps to offset the character's height in response to the height of the cover, so we have more options than just high and low. Let's first save this to a cached pose. Call this one post-skeletal control. We need another blend pose by bool here. Condition to check is our in-cover boolean. If in cover, we bring out the SCS control rig interface. For instance class, we need to select SCS layer. If not in cover, we run through Lyra control rig. This is also a control rig, similar to this one, but I added more controls to adjust height and packed it into an interface for convenience. Now you can see our character going higher and lower, responding to the cover height. We are near the end now. Just some loose ends to tie up. For example, this AD's issue shouldn't happen. Instead, it should trigger a switch hand event. For that, we need to modify the AD's ability. You can search for DA_ADs in the plugins folder. At Event Activate Ability, we need to make some space and add a branch here. Then get our player pawn. From this, we can call an interface, SCS get character values. Split the struct. We don't need to switch hand if we are using a pistol, so let's do a weapon type check. If equals to one-handed, we do nothing. If false, we add another branch. This time we check if we are holding our long weapon in the correct hand, based on the facing direction, so call this interface from our pawn reference. Try get SCS component. From here, we can get a boolean called face left. We need to check if this value is the same with tool wield status equals to main hand and off. If it's true, then we are holding the weapon in the correct hand and can continue to trigger ADs. If false, we need to call switch hand function and end ability. Don't forget to feed this face left value into this interface. Let's compile. Oops, I forgot to connect these interface calls. Let's get character value first, then get SCS component. Now we are good. One small issue, the switch hand function continues to trigger, so we need to add a blocker. Let's cast our pawn to character. From there we can get a mesh reference. And then an anim instance. Here we can check if there is any montage playing. If not, we can go ahead and attempt to switch hand. If true, we just end ability. Might also want to add some debug info here, in case the cast fails. Another thing we could improve is, SCS has the ability to detect if the cover is blocking our view, and prevent the character from firing or aiming down sight. We can set it inside GA_ADs as well, but first we need to make a gameplay tag. Let's go back to our BP_hero. At our tick event, let's add a pin on the sequence. From here we add a branch. Need to check if we are in cover. If not, we don't need to do anything. If true, we can monitor a value from SCS component called blocking fire using the value change macro. If this value changes, we check if it changed to true or false. If true, we add a loose gameplay tag. If false, we remove it. The actor reference, we just need a reference to our character, so add a reference to self. Make sure to check this should replicate option for both. Now, I don't believe we created this tag yet, so let's check our project settings first. We can add the tag manually in this section, but it could get difficult to manage. My preferred way is we add it using a data table. Go to our SCS Blueprints folder. Let's add a new folder. Call this one data table. In here we add a new data table from the MIST section. Row structure, we want it to be gameplay tags. Then we rename this to DT_SCS tags. Inside this table we add a new row and the tag we need to put in cover.blocking. Now we can add this table to the list of tags we are using. So back in project settings, add a new list here, DT_SCS tags. Now you should see it here. Back to BP_hero. Now we promote this tag to a variable, so we can give it value. Make sure you have blocking checked. Moving on to the AD's ability. From our second branch, when true we set camera to AD's mode, we need to add another branch here. From our pawn reference, drag out a line and add a has matching gameplay tag node. Tag is of course cover dot blocking. Add a branch here. If the value is true, then we need to end ability because we are being blocked. If false, we can go back to the rest of the AD's process. Not done yet. If we are in AD's mode but starts rotating the view to a blocking position, then we will need to end AD's right away. So from here, let's add another node called wait gameplay tag add. If added, we end this ability. Link this upper pin back into the is valid check. Time to put it to a test. Looks good. When in a blocking angle, we cannot aim. But if we move away, then we can aim again. If we rotate back, ADs will also be cancelled, same for facing left. That's aiming. We need to add this to fire ability as well. This ability is in the content folder called GA Weapon Fire. You should be able to copy and paste the part we added in GA-ADS. So I'm gonna skip this part. If you are having trouble, leave me a message or contact me on Discord. Next, we need to get cover-to-cover move setup. If I remember correctly, we didn't add it into our IMC yet. Let's do this now. In our BP_hero, it should be easy to locate the part we add this mapping context. Browse to its folder. With enter-exit cover mapped to Z, we can add a new mapping, IA_cover to cover and map it to V. Now that we have the context, we can bring this input action into our character BP, IA_cover to cover. Then we should do an is any montage playing check. If false, we can grab our SCS component and call the RPC SCS cover to cover function. And that's it. Let's do a quick test to see how it works. That's good. Another issue I noticed after we finished hand IK, there's a bit of issue with height offset when aiming down sight and cover. It's probably due to ADs being handled by Lyra, and we didn't update the value required by SCS. Seems we didn't plug AD's value into this interface. We already has AD's value worked out at the tick event, so just plug it in. But we do need to make sure it replicates. Let's also set these other variables to replicate as well. This firing value is also missing. Let's set its value in the tick event as well. First, create a Boolean variable named firing. If you still remember, we did this in the anim graph, used a float value for this, so we can grab that value from our main anim instance. Go to begin play. After we initialize SCS component, get our anim instance and cast it to ABP_mannequin base. Save this reference to a variable. Now we can use the value called hipfire upper body override to set this variable. If it equals 1, set it to true. Now we can plug this value into the interface. Also, make sure all these variables are set to replicated. One more thing we need. Grab an SCS component reference, then get a Boolean called canMove. It's replicated, but I noticed some replication delay issue in Lyra, which caused a slight delay on the client side. We are just gonna save this value here and make it replicate. This is to make sure both server and client has a timely update of this value. Let's see if this problem is fixed. Looks good. Now I think it's time to move on to multiplayer test. We need to have at least 2 player and switch to listen server mode. A couple problems. The client side seemed to have trouble when attaching weapon, and we might also have an issue with the logic we added in ADS ability. The message log also indicates some missing reference. This is likely because the weapon actor isn't replicated, and client side doesn't get a weapon actor. Let's try setting it to replicated. See if this would solve this issue. That did the trick. Although it seems I missed something when adding the custom logic in GA_ADs, it's forcing a switch hand when aiming with left hand. This should only happen when in cover. This error message says we are missing the reference when trying to set weapon. Let's go add a is valid check in front of the setter. Good, problem solved. Let's get back to fixing GAADS. Before we do this is-handed check, we need to add a branch, grab an in-cover value from SCS component interface. If true, we run through this custom logic. If false, we go straight to set camera mode. Don't forget to add this to gay_weapon fire as well. Let's see. This is no longer an issue. Let's see if everything else is in place. One more problem. Seems when the client side is moving to the edge of the cover, it's not being stopped immediately, and went over a little, and that's too much exposure. This is likely the same replication issue with Lyra. Sometimes some values are not replicated immediately, with roughly half a second delay. A known example is acceleration. Its replication is handled in the SEP class. On the client side, it's not being updated in time, which can cause an issue with distance matching stop animations. Anyway, to fix our problem, We can change some setups in the SCS component. At Agent tick, we can see by default we are skipping this calculations on the remote side, waiting on server to replicate these values to our proxy. Let's change this up a little. Skip this switch has authority, but make another one here before enter left. If on the server side we set this enter left value, if on the remote side, one other issue here, when turning around in cover, we can see the client-side animation has a bit of stutter. This is probably because of the same replication delay. Let's go change some settings. Back in SCS component, search for face left. One of these setters should bring us to this event, MC cover turn. You see we are skipping this setter on the remote side and waiting on the replicated value. Let's skip this switch and add a new one after we set this value. If we are server side, then trigger this. If not, we loop back to reset the do once node. This should do. Now I want to test it against the bots, see if cover gives me some advantage. Probably not, but at least cover systems works fine. That's the end of this tutorial. There might still be some bugs needs fixing, if you find any, or if you need help, leave a comment or contact me on Discord. I will look into it as soon as I can. Have fun and see you in the next one.